Let's review my example solution for day 2's assignment. First up, we need to require in the inquirer and yargs packages. We'll then ask for two options from the command line. The first one is number 1, and the second one is number 2. Make sure we describe these two types as numbers so that we don't have to parse them into integers later. We'll store a reference to these numbers once we get them back. Now using inquirer, let's prompt for a mathematical operator. We're going to specify a list type and provide all of the mathematical operators that we want to have as options as choices. We can then use numbers that we got from the command line as part of the message asking which operator we should use. Let's filter the return through an uppercase filter so that we don't have to deal with any case mismatches. Once the user provides an answer to inquirer, we're going to use a switch statement on the answer that they gave. For every case, apply the operator for that case to the two numbers that we received. Make sure you break afterwards. Always provide a default value as well. And then we just log out the answer. Section 3. Callbacks and promises. Working with the event loop. We're going to be covering asynchronous programming, which is a key aspect to working with Node.js. We'll cover what the event loop is, whether or not there are separate threads in a Node.js application, when your code gets to run in the event loop, and how you can utilize multiple cores of your system in a Node.js application. So, what is the event loop? The event loop is primarily a loop, as the name suggests, that contains several phases. These phases are repeated continuously, and each phase runs a set of tasks. The event loop is what keeps a Node.js application running. Node is an event-based system, so everything that happens inside Node is in reaction to an event. Under the hood, this is all handled by a library called libuv. Let's take a look at a diagram to try and explain things. Now, I've borrowed and modified this diagram from a post by Daniel Kahn. I've included the URL here at the bottom of the slide, so please read his post to gain a more in-depth understanding. He was motivated to write his original blog post due to the amount of misinformation about the event loop that seems to be present on the internet. So I want to make sure that you have access to the best information to try and get this right. In this diagram, time is passing from left to right, and as time passes in ticks, a different phase of the event loop is processed by libuv. The first phase is timers, so anything you've scheduled with set timeout or set interval will be processed. Bear in mind that the timeout that you specify with these commands is the minimum amount of time that will pass before the callback is run. So if you've set a timeout for 1000 milliseconds, the callback won't ever be run at 999 milliseconds, but it might not actually be executed until 1010 milliseconds due to OS scheduling or other callbacks delaying the execution. Next up is I/O callbacks. So this is really any code that contains a callback, for example, an incoming HTTP request, a completed callback from a database server, or anything of this nature. Next, libuv will poll for any events that need to be processed in the next event loop. Once the poll queue is empty, the event loop will now check for any timers whose timeouts have been reached, and if there are any, the event loop will now wrap back to the first phase and execute those callbacks. There is a hard limit set by libuv that controls how many times. There's a hard limit set by libuv that controls how many times this loop will occur. If you set any callbacks using setImmediate, these will be invoked in the next phase. Finally, if a socket or handle has been closed abruptly, the close event will be emitted in this final phase. You can also see on this diagram that each phase of the event loop has a first in, first out queue of callbacks to execute. Generally, when the event loop processes a phase, it will perform any operations specific to that phase and then execute callbacks in that phase's queue until the queue has been exhausted or the maximum amount of callbacks have been executed. After each run of the event loop, Node checks to see if it's waiting for any asynchronous I/O or timers, and it will shut down cleanly if there aren't any of these. So if your application is mysteriously exiting with no error message, it may simply Node believes there's no work left for it to process. Now the event loop can be very tricky to understand, so if you're still not clear, you can find a more in-depth discussion on the Node.js website, and I've given you a link here on this slide. In my experience, as long as you stick to the relatively simple set timeout and set interval calls, most of the event loop is basically transparent to you when you're writing your Node applications. If you're getting into code where you need absolute control over the event loop, that's when it's important for you to fully understand every facet. So, with this event loop going on, are there separate threads for the event loop in your application code? Well, no, this is a misconception. There's only one thread running JavaScript code, and that thread runs the event loop. The event loop is what runs your code and all the callbacks. So when exactly does your code get run? Primarily, this is in the first two phases of the event loop, when it handles timers such as setInterval and setTimeout, and the IO callbacks phase. Node also features the setImmediate call, which is designed to execute a callback once the current poll phase completes. The order in which timers are executed varies depending on the context in which they're called. So let's take a quick look at that now. Here we have a setTimeout with a timeout of 0 and a setImmediate. In this context of not being inside an IO cycle, the order these callbacks will run in is non-deterministic. If we run this code a couple of times, we'll see that the order changes. So let's execute it once, and the first one to come back is the immediate, and then timeout comes out afterwards. Run it again, it's the same, run it again. And this time, timeout came back first, immediate came back second. If we wrap these callbacks in an IO cycle, however, setImmediate will always execute first. Here's immediate straight away, and it doesn't matter how many times I run this. Immediate always comes back first. Node also contains an API function called process.nextTick. However, its usage is quite complex and has some edge cases, so in this case I'd strongly recommend you follow the official Node.js documentation for advice on whether this API feature is something that you should be making use of. So if your server, for example, has many cores on its CPU, how can you use more than one of those cores if Node is only single-threaded? Well, the answer to this is the cluster module that's available in Node. This module enables you to have a master application and then several child processes that will all run on a different core, and these child processes perform work for that master process. I've put a link in this slide, and you can go and look at the API for how to run clustered Node applications.